So now in this video we look at the final project of my voltage booster projects. I've been building up to this. It's not wired up yet completely. We have the power on. We can actually remove the switch. I should have removed that sooner. That gray jumper could be removed too, but I'm not going to do that right now. We're going to go to the output of the 555 timer. So most of my prototype boosts, I would just press in a switch to get a look at how much each pulse basically we get will give us some extra voltage. But here I got to go down to that capacitor right there. I didn't want to block the LED, so I wired up that side first and this side first and then that side second. This is providing power, so if I plugged it into the wrong spot I might fry something. So normally I would plug that one first and that one. But in case, you can see we got 5 series LEDs right here, and they're glowing fairly decently. I'm guessing maybe about 0.6 amps of current going through there, less than 1 milliamp. I'm going to raise the supply voltage to 5 volts right there, and you can see looks like we got an average of it's going up now, but that's probably the average current for mostly the inductor, but some other stuff, and that may be about 1 milliamp of current right there. I'm guessing. We can measure that later, but you can see we need a lot of current coming in. I have this set to 0.2 amps, 200 milliamps of current. Every once in a while this power supply has to provide close to that. It's real brief though, just to get current going through the inductor. You can see if I drop the maximum current to 0.1 amps, so that's 100 milliamps. Sometimes more is demanded of the power supply, but the power supply says, nope, that's all I'm going to provide. That's what CC means. It provides 100 milliamps of current when the load wants more. It just sets the current, and to do so it has to drop the voltage. So we will do that right there. You can see it's not quite 5 volts, and when we bump this up 200, now you can see it's holding a steady 5 volts there. So I had to drop voltage briefly to limit that current. Thought I would add that. So now to begin with, we're going to look at this 555 timer, which is our clock right here. It keeps going high and low right there, which other circuitry responds to. In this case, it responds to when it goes low for the most part. Other than this responds to both the high and low. So we got the 555 timer there. It's just wired in astable mode right now. And to keep things simple, I didn't add a diode. I went to a website that had a calculator. You enter these values and it gives you the results that you should expect. So it's 48 hertz. It goes high and then low. 48 times a second is what it's basically saying, and so you got your period. That's that amount of time it goes high and low. 20.79 milliseconds right there, so much faster than what I could press and release a button. And then duty cycle means that since we don't have a diode there, it would be closer to 50%. If we did, it would be high and low about the same amount of time. Since we don't have that extra diode, it has to charge through 2 resistors, and so it's going to be high twice as long as it's going to be low because it discharges through only 1 resistor. So now that jumper I added right at the beginning of the video came to pin 3 down there up to where this 10K resistor and capacitor right there connect, and of course power is off, so those LEDs are not going to light up right now. And that comes to this point here, as I said before. That means we can change the voltage of this capacitor pretty easily. But we don't want number 2 here, the trigger pin, to be low for very long. We just want it very briefly low, just enough to trigger the 555 timer, start charging this capacitor. We want it to be high before this capacitor is done charging, because once this capacitor charges to 2/3 supply voltage, if we're still high on pin 2, it's just going to keep charging, which we don't want. We want it to discharge at that point. Pin 2 is more powerful. So we want as quick of a pulse to pin 2, that is low, by the way, connected to ground, as possible. And just enough to trigger the 555 and then go back to it being high. So we have this pull-up resistor that helps hold it high, and also it gives us a path to discharge the capacitor so that it can go back to a neutral, and thus the pull-up resistor is holding it high. But when we get a low pulse here, then current sucks this way. We're going positive to negative, that pulls down the voltage at pin 2 until that capacitor charges up. Then you get to 5, and thus that gives you another high input to pin 2. It stops doing anything. So when this gets to 2/3 supply voltage, then it can discharge to ground and set the output low. So now moving on to the other timing. As I said before, that's our pulse. We just want a real brief low pulse no matter how long the output is low, because this needs to be high by the time this gets to 2/3 supply voltage. To set the timing for how long we're going to let current pass through the inductor and transistor, because it does take some time before it builds up the current. Inductors don't like sudden change of current. So we get that low pulse. This capacitor starts charging, the output is high. We want to make it so that by the time this gets to 2/3 supply voltage, the inductor is fully conducting. As long as it's fully conducting, then it's not going to conduct any better. That's the best point to stop that conduction. So hopefully that 2/3 supply voltage is right about that exact time, and then you get to 2/3. As long as that is high, then it will discharge through pin 7 to ground instantly, and the output will go low. The output will stay low until we get another low pulse to 2, and that whole process will start again. So 10K resistor, 0.47 microfarad capacitor. I mostly grabbed that capacitor because I already had one available on the board. It's a low value, so things will go quick. And 10K resistor, I tried different value resistors, and 10K seemed to be as good as I could do for the most part. And of course, we always have to power both integrated circuits, 8 to the positive supply, 1 to the negative supply, and also you'll see on both of them, number 4 to the positive supply, that's the reset pin. We don't want it to do anything, so we hold it high. If it gets a low input, the output will just stay low. Jumping over, we have a 1000 ohm resistor coming from the output there to the base of the transistor. That's because we need some current flowing through, a lot less than what the inductor needs, but a fair amount. And so we're going to get almost 3 to 5 milliamps, a little bit less, going base to emitter to ground. That way, when the output goes high, so you can see that path there. Well, the output is high, also the transistor will conduct that way. And I have a 10 millihenry inductor. That's the best ones I have. They have about 25 ohms of internal resistance. That will be what mostly sets the current. There may be some other factors, but that's primarily it. So there's going to be a fairly high amount of current flowing once it gets going. It doesn't start instantly. So we have to be high enough for it to get conducting fully. And then we want to turn the transistor off instantly, hopefully. And that means the current that's flowing through the inductor, it's not going to stop instantly either. So if all we do is try to stop with the transistor, it might fry the transistor. It's going to force current through it. So instead we have a diode here. So the gray band for the diode I'm using is towards the more negative side of the circuit, headed to ground there. And the anode over there is connected to the inductor and collector. That current can pump this direction. So it's going to pump into the capacitor unless the capacitor has enough voltage where it can go through the series LEDs like that. And so if we don't have these LEDs, we're in danger of, just like we could fry the transistor, we might fry the capacitor if its voltage gets too high. So it's like 50 volts or something. As I said before, we're shooting for, you know, maybe 15, 20 volts if we were lucky with these LEDs, but this is not practical enough to actually do so. We're just barely getting enough voltage for them to light up, you know, somewhat okay, maybe 1 milliamp of current. And so the LEDs are protecting the capacitor from over voltage at this point, doing a really good job. But in case, as I said before, to really get these bright, like 10, 15 milliamps, we would need 15 volts just for the LEDs, plus 1 volt for every milliamp of current. So about 5 volts more, because each volt is 1 milliamp current when it comes to a 1000 ohm resistor. We could use a lower value resistor though. I picked the 1K because it's easy to measure across it and see how much current is flowing through it. So now in the last video I forgot to mention this. I'm using the 2N2222 because as we saw with the power supply, we get, maybe up to almost 200 milliamps of current flowing through the circuit. This transistor, 2N2222, can switch 600 milliamps of current, well below that. The 2N3904 has an absolute maximum though of 200 milliamps of current, and so I feel it's better to use a transistor here that can handle higher currents in this circuit. And zooming into the circuit, we got the output there. It goes high, a little bit of current from a base 2 emitter right there headed to ground, allows much more current to start flowing through the inductor and transistor like that. And then it goes low, transistor stops conducting, current still wants to go through the inductor, so we have the diode right there. And that's the gray band right there. You may be able to see it, maybe not. But current's going to flow that way and charge up the capacitor there, which goes to ground. Now, we also have a path to ground through the LEDs. Once voltage gets high enough, I think 11 volts it looked like last video, a little bit of current starts going through them, and the current limiting resistor, which doesn't really do a whole lot in this video because of the low voltages we're dealing with. Again, if you need a practical voltage booster, buy a voltage booster module. But in any case, hopefully that all made sense right there. So now for those of you that stuck around this long, I think we'll just take a multimeter measurement. So right now the power supply is off, but the capacitor is going to hold a voltage for a period of time because the LEDs don't conduct at lower voltages. And so we got about 9, and it's gonna drop a little bit quicker now because we have the multimeter. But this has like 10 million ohms of resistance while it's measuring voltage, and so it's not dropping terribly fast. But there we go, we applied power, LEDs are on, and across the capacitor we're getting about 11.6 volts. So now that's 3 volts in. We're getting 4 times the voltage out, being limited by the LEDs though. So that means current we're getting through the LEDs, if things were perfect, would be 1/4 the amount of current that goes through the inductor. And remember, we had brief periods of high current, but then when the transistor is off and the inductor is done passing current, it's going to be off for periods of times too. So we don't know the exact efficiency, but in any case, that's with the 3 volts at the power supply. Let's see the voltage we can get if we bump this up to 5 volts. So more current's going to flow through the inductor. It's going to be able to pump out more voltage. But there again, you can see it's really these LEDs that are limiting our maximum voltage right there. So now we'll zoom in for a better look. I dropped the voltage back to 3 volts across the capacitor. As we saw before, we have, looks like about 11.6 approximately. And here is our resistor. So I can't open up the circuit because the capacitor would overcharge. And so we are just going to measure the voltage across the 1000 ohm resistor. And so if that was 1 volt, we'd have 1 milliamp of current going through these LEDs. It's not even close to that high. It's like a point, I'm just going to round it off, 0.2. So we have about 0.2 milliamps of current going through the LED. So that's with the power supply at 3 volts. Now I'm going to bump it up to 5 volts, and we'll measure the resistor there. And there you can see 0.3. So I think I was doing better for some reason before. But there you can see we have about 1/3 of a milliamp of current, it looks like, going through those LEDs right there. So not much current. Again, I could probably improve this. I spent a lot of time trying to get as good as I could, but of course it could be improved. But just buy a voltage booster. They're far more effective, but this is still a fun project and challenging project.